Today we're going to look at circle theorem 5. This is the alternate segment theorem. So we've got a diagram here of a circle, we've got a tangent here and a chord that meets that tangent. We want to prove that the angle that the chord makes with the tangent is equal to the angle in the alternate segment. So we want to say that A is equal to B. I'm going to start this proof by drawing a radius from the centre to that point on the tangent and from the centre to the corner of the triangle there. I'm going to split this in half and I've made two right angle triangles here. So I've got a right angle there and a right angle there. I'm going to label this angle here angle X and this angle here angle Y. Now because we've got a radius here and a radius there, these lengths, the hypotenuse of each right angle triangle is exactly the same, the height is exactly the same, so the angles must be the same as well, as they are similar. Now thinking about the circle theorems we've already seen, we have discussed that the angle that the radius makes with a tangent is 90 degrees. So we know that X plus A is equal to 90 because the radius meets the tangent at 90 degrees. I'm also going to use a property of the sum of angles in a triangle. I know that X plus Y plus 90 degrees is equal to 180 degrees because the sum of angles in a triangle is equal to 180. I'm going to subtract 90 from each side of this second equation here, and I get that X plus Y is equal to 90. Now if we compare the first equation with the third equation, we can see that A must equal Y. But I'm going to show you that mathematically by substituting this equation into that equation there. So I'm going to call this top equation equation 1 and this one here equation 2. I'm going to rearrange equation 1 to make X the subject, and I get X equals 90 degrees minus A. I'm now going to substitute this equation for X into equation 2. So wherever I see an X in equation 2, I'm going to substitute it for 90 subtract A. So I get 90 subtract A, that's my value of X, plus Y equals 90. I'm going to start rearranging this. I'm going to subtract 90 from each side and I get negative A plus Y equals 0. I'm going to rearrange this to make Y the subject by adding A on each side, and I get Y equals A. Now our previous circle theorems that we've looked at, we've also seen that the angle at the centre is twice the angle at the circumference, or 2 lots of the angle at the circumference is equal to the angle at the centre. So we know that 2 lots of angle B is equal to the angle at the centre, which is Y plus Y, or 2Y. So I'm just going to rewrite that as 2B equals 2y. We've just found out that y equals a, so if I substitute y equals a into this equation here, I get that 2b equals 2a, and if I divide both sides by 2, I get that b is equal to a. So these two angles are equal. Make sure you get this proof written down. We're going to now move on to our I do, you do task.